To prove that this expression here, this quadratic expression, is positive for all values of n. So how do we show that a three-term quadratic is positive, okay, for all values of n? Well, we use completing the square method. Okay, so if you recall completing the square, we can actually show that this will never be negative, and in fact will always be positive. Right? So by completing the square, if you remember what I do, we have a bracket and we put n in that bracket, and if you remember, you've always got to halve this. Okay, so because it's minus 8n, halve that, you get minus 4, right? So halve that number, and then you square it, and then you always take away the square of this number, which is 16. Okay, always take away the square, whatever that number is, 16, and then you add the 20 on here. So we get n minus 4 all squared, and then minus 16 plus 20 is plus 4, isn't it? Okay, so that's what n squared minus 8n plus 20 is equal to. It's equal to that. Now, think about this logically, okay? If that is equal to this, well, it's always got to be positive, isn't it? Because this is always going to be positive, okay? Clearly, the first term here is going to be greater than or equal to 0, isn't it? So since n minus 4 all squared is greater than or equal to 0, okay, it's got to be positive, because a square can't be negative. It could be 0, but then when I add 4 to it, it's just always going to be positive, isn't it? So therefore, n squared minus 8n plus 20 is always positive.